Ethanol, found in alcoholic beverages, significantly affects the human body and mind. Upon consumption, ethanol is absorbed into the bloodstream primarily through the stomach and small intestine. The presence of food in the stomach can slow this process. Once in the bloodstream, ethanol disperses throughout the body, affecting various organs, including the brain. Factors like alcohol concentration, consumption rate, and individual physiology influence absorption speed. Consuming ethanol on an empty stomach leads to quicker absorption and rapid onset of effects. Ethanol easily crosses cell membranes, acting quickly on the body. Its ability to dissolve in water and fats allows it to penetrate tissues and the blood-brain barrier effectively. This rapid distribution contributes to the immediate psychological and physiological changes experienced during alcohol consumption. Once absorbed, ethanol is primarily metabolized in the liver. This breakdown occurs in two main steps, facilitated by specific enzymes. Alcohol dehydrogenase, ADH, converts ethanol into acetaldehyde, a highly toxic compound. Aldehyde dehydrogenase, ALDH, then processes acetaldehyde into acetate, a less toxic substance. The liver's ability to metabolize ethanol determines the duration and intensity of intoxication. The rate of metabolism is generally constant, meaning the liver can only process a fixed amount of alcohol per hour. Genetic variations can affect the production and efficiency of ADH and ALDH enzymes, leading to differences in how quickly individuals process alcohol. Understanding ethanol's breakdown in the liver provides insight into managing intoxication and the body's efforts to eliminate alcohol. Ethanol's influence on the brain is significant due to its interaction with various neurotransmitters. It enhances the effects of GABA, an inhibitory neurotransmitter, leading to reduced neural activity and relaxation. Ethanol inhibits glutamate, an excitatory neurotransmitter, contributing to its sedative qualities. This dual action on GABA and glutamate helps explain ethanol's ability to alter consciousness and reduce inhibitions. Ethanol also impacts the brain's reward system by facilitating the release of dopamine, contributing to feelings of euphoria. Additionally, ethanol stimulates the production of endorphins, natural painkillers that enhance mood and reduce stress. These interactions form the basis of ethanol's psychoactive effects and highlight the potential for alcohol to become habit-forming. The effects of ethanol vary widely due to differences in genetic makeup, body composition, and personal drinking history. The ratio of fat to muscle in the body can influence blood alcohol concentration, BAC. Typically, women have a higher fat-to-muscle ratio than men, leading to higher BACs when consuming the same amount of alcohol. Genetics play a critical role in how individuals process and respond to ethanol. Variations in genes encoding for ADH and ALDH enzymes can lead to differences in alcohol metabolism rates. Some East Asian populations have a genetic variant resulting in an inactive form of ALDH, causing adverse reactions to alcohol. Personal history and patterns of alcohol use can influence tolerance levels. Regular consumption of alcohol can lead to increased tolerance, where individuals require larger amounts to achieve the same effects. Understanding individual differences in ethanol tolerance and metabolism underscores the complexity of alcohol's impact on the body and mind. Ethanol's interaction with neurotransmitters like dopamine and endorphins contributes significantly to its addictive potential. The pleasurable sensations driven by increased dopamine release mimic the effects of other addictive substances. Over time, the brain may adapt to these elevated dopamine levels, leading to tolerance. This cycle of increased consumption and tolerance can lead to dependence, where the absence of alcohol results in withdrawal symptoms. Genetic predispositions can increase the risk of developing alcohol dependence. Recognizing the addictive potential of ethanol is crucial in understanding the risks associated with its consumption. Addressing these issues proactively can help mitigate the long-term negative consequences of alcohol addiction. The long-term effects of ethanol consumption extend beyond addiction and immediate intoxication. Chronic alcohol use can lead to persistent changes in neurotransmitter systems, affecting mood, cognition, and behavior. The liver, responsible for metabolizing ethanol, bears the brunt of long-term alcohol exposure. Chronic consumption can lead to liver damage, manifesting as fatty liver disease, hepatitis, or cirrhosis. These conditions compromise the liver's ability to function, affecting overall health. Prolonged alcohol use can impact other bodily systems, increasing the risk of cardiovascular disease, weakening the immune system, and contributing to certain cancers. Addressing the long-term health impacts of ethanol requires a comprehensive approach that includes education, early intervention, and support for those affected by alcohol dependence. By understanding the potential risks and taking proactive measures, individuals can reduce the harm associated with alcohol consumption and promote healthier lifestyles.